Welcome to solverfy.
We're looking at more problems on friction and screws. Consider the diagram shown in the board. We want to determine the compressive force BC there that could be applied. Okay. Uh, to solve this problem, what we need to do is to determine the required equations to use, as well as apply uh, equilibrium to the system, bring out the appropriate diagrams to help in the solving the problem. Okay. Now, for the system that is shown here, we are looking at considering uh, screwing through two wedges. So we are going to apply, and we are tightening. So we are going to have this equation to be equal to 2, okay, arrow the mean radius of the screw, okay, then W, the clamping force, and lead, the lead angle plus the angle of static friction. Okay. Now we know that we can get the radius because we are given the diameter of the main diameter in the question. So when we do that, we divide, just plug in the value there. You're going to arrive at in meters, not converted to meters, or working in meters rather. We're going to have it to be 0.0125 as the meters as the mean radius. So we know that moment, that m that is there, that torque moment is force times uh, distance, the particular distance. Okay. So if we do that, we multiply that. Of course, we are given the force, okay, that is applied, okay, to obtain the moment to be 100, 100 IB. So, sorry, it's 100 Newton. So by the time we multiply by the distance, the particular distance there is 0.25 meters, okay, in meters. Okay, it's 0.25 meters. So that is going to give you 25 Newton meters. Okay, so that is what M will give you, the moment there will give you. So we can now look forward for the lead angle. The lead angle, all we need to do is to apply the arctan, okay, arctan of the lead over 2 pi arrow, and this information, the information is there already. So just plug it in there. When you plug it in there, you're going to arrive at your lead angle. Sorry, you're going to arrive at your lead angle to be equal to 5.45 degrees. Plug in the lead. Lead is given, okay, is 0.0075 in meters. Plug in that you have there. Then you also look for the angle of static friction. To get that one, you apply the arctan, okay, of the coefficient of static friction is given, okay. So apply it there. When you apply it, you are going to arrive at your answer to be equal to 8.53 degrees. Okay, so that is the angle of static friction. So we can now make W the solute of the formula. If we make W the solute of the formula there, we are going to arrive at that force there to be equal to 4,003. Just apply everything into the equation there. You arrive at 4,032.3 Newton as W. Of course, W is equal to the tension, this T that is going out there. So therefore T, okay, is equal to W is equal to 0.32.3 Newton. Now we cannot consider equilibrium, okay, for the wedge one there. If we do that, look at equilibrium in the horizontal direction, we are going to have minus F. We're going to have minus F uh, at the frictional force at A, as it has been labeled. Yeah? You have this one, frictional force at C, or frictional force based on the labeling, cos 15 degrees, cos 15 degrees. So we'll do that minus the normal reaction, see, sine 15 degrees plus t equal to 0. Okay. Then when you also consider equilibrium in the, of course, you have to plug in all your values into the plug in all the relevant values. Okay. You arrive. Okay. You have that. You can also consider equilibrium in the in the vertical direction. If you do that, okay, you're going to arrive at NA plus F A sine sine 15 degrees minus NC. I remember when plugging, when working on F, the F sub 3 or F sub A, that you have to convert it, that F is mu, N is mu times the normal reaction. This is the coefficient of static friction times the normal reaction. Don't forget. Okay, so we have NC cos 15 degrees equal to 0. Now you can just call this, you can call this equation 1, plug in all the values into equation 1. Okay, call this equation 2, plug in all the values for coefficient of static friction. Okay, and your cosine and your sine, plug them into your calculator, and you arrive at your NC to be equal to 6, 3, 4, 2.09 Newton. Okay, and you also arrive at you solve the two equation 1 and 2 simultaneously. Okay, you arrive at NA equal to 5, 7, 9, 6.7 Newton. Okay, haven't done this, you can also proceed to the wedge 3 as it is labeled there. Okay, you take summation of forces in the vertical direction. So yes, in the vertical direction for wedge 3, it's labeled there, go to 0. Okay, now the forces there, consider the equilibrium. You have minus PC. Here PC is the compressive force we are looking for, minus FC. Okay, sine the frictional force at C as it is labeled in the diagram, 15 degrees. Okay, plus N NC cos 15 degrees, okay, minus FC. Now this is FC prime sine 15 degrees, okay, plus NC prime cos 15 degree, okay, equal to 0. Now the values you've gotten already, you can plug them into this equation, and don't forget to convert F, that is frictional force, uh, to by applying the quotient of friction to it, so that you become mu times the normal reaction. So when you solve this, you are going to arrive at, of course, you plug in NC, NC prime is equal to NC. Okay, when you are solving, you arrive, when you do that, you arrive at your P C to be equal to 116. Okay, 116 11644.08 Newton, which is the same thing as equal to 11.64 kilonewton. So this is the compressive force that is required.